All right, so today we are going to continue our look at the imaginary number I, and I've continued with a few more examples for you, and you can just follow along. Like I've mentioned before, it's probably a good idea to print out the guided notes so you can kind of follow along and annotate as we go. So I'm going to go ahead and get started with this first example 4a, which is 2 over 3i, and I apologize, but Word is doesn't like the way that I formatted this, so that's why that blue squiggly line is across. So when we're taking a look at a problem like this, just like when we were simplifying radicals, we couldn't leave a radical in the denominator, and the same is true with an imaginary number. So we need to somehow turn the denominator into a real number. So we need to remove that I. So what we're going to do is we are going to multiply the numerator and denominator by I over I, so that when we multiply horizontally, we get 2i over 3i squared. And then if you recall, by definition, I squared is -1. So that equals, I'm just going to actually bring this down here just because I have more room. So this now becomes 2i over 3 times -1, which then simplifies to 2i over -3. And then you just need to ask yourself, is there anything that you can simplify? And the answer is no. So we're going to go ahead and leave that in that form, 2i over -3. All right, let's take a look at part B. So as we talked about yesterday, the inclination would be to multiply by the square root of -2 over the square root of -2. But we first need to simplify it as an imaginary number before we can move forward. So instead of doing that, what we're going to do is just first simplify this so that we get an imaginary number. So this still becomes 6 on the numerator, and then on the bottom I can pull a -1 out. So this becomes I times the square root of 2. And then what we're going to do is we are going to multiply our numerator and denominator by I square root 2 over I square root of 2, so that we can rationalize that denominator. Okay, and then that answer to that problem, I'm going to bring this around, and I'm going to rewrite this as 6i square root of 2 over, and now I have I squared times 2. And actually, let me rewrite that as 2i squared. Okay, and then now we can go ahead and simplify that further. This is going to be 6i square root of 2 over -2. And then finally, I can divide 6 by -2, and I get a final answer of -3i square root of 2. And that would be my final answer there. Okay, now before we start that next one, I'm just going to draw a line. I apologize, we're running out of room. I should have probably put a little bit more room on this before we start this next one. Okay, so the first thing that we're going to want to do again is we are going to want to simplify this in terms of imaginary numbers. So we're going to think back to our list of perfect squares, and we're going to need to break down this square root of -18. So that is going to be broken down into, if we could do square root of -9, right, and the square root of 2, this is 3i, right, and then we still have the square root of 2. So this numerator, if I combine everything, my 4, my 3i, and my square root of 2, I end up with 12i times the square root of 2. Okay, and then we're going to break down this negative 12. So that's going to be my negative 4, and then I've got my positive 3. So this breaks down into 2i. So then my denominator simply becomes 2i times the square root of 3. Okay, so before we move on, we can go ahead and simplify this fraction before we take care of rationalizing the denominator. So I've got 12i divided by 2i, so that's just going to be 6 times the square root of 2 over the square root of 3. Okay, and then let's go ahead and rationalize our denominator. So we're going to multiply by square root of 3 over the square root of 3. And that's going to give us 6 times the square root of 6 over 3. And then our final answer when we simplify is going to be 2 times the square root of 6. That will be that answer. All right, and I know that that was a lot of steps, so please make sure that if you're getting lost, go back and rewind and hit pause and make sure that you really follow it through. And again, I'll be available for questions as you complete your assignment if you get tripped on something. All right, so let's jump down to example 5. So we're asked to simplify and assume that each variable represents a positive real number. So as in the examples that we did above, we want to first simplify everything in terms of our complex or our imaginary numbers. So if I were to simplify this square root of negative 9x squared, I could turn that into 3xi. And then I could turn my negative x squared, the square root here, that just becomes a positive xi. And then we're asked to just simplify that a little bit further. So if you notice, they are like terms. So I can say that this now just would be equal to 4xi. Okay. All right, so let's take a look at part B. So part B, if I were to simplify this, the only thing I can really simplify, because I can't break 6 down into perfect squares, I could just make it, I could pull the I out. So this now becomes I times the square root of 6y. And the same is true for the negative 2y. The only thing I can pull out is an I. So this becomes times I square root of 2y. All right, so let's go ahead and multiply everything together. So my i's and i's make an I squared. And then I have the square root of 12y squared. Okay, so now what we can do is let's go ahead and break up our 12 into, we could say this is 4y squared, and then this could just be a 3, square root of 3. So let's go ahead and find the answer to each of these. So I squared gives me negative 1, and the square root of 4y squared gives me 2y. So my final answer when I combine all three, so I've got this negative 1, I've got this 2y, and I still have this square root of 3. So this becomes negative 2y times the square root of 3. And that would be your final answer for example 5b. Okay, we've just got 2 more examples to run through, so let's go ahead and scroll down a little bit further to this last example 6, where we're asked to solve these equations. All right, so we've got 2x squared plus 19 equals 3. So as we've looked at before, we need to isolate the variable. So what we're going to do is we are going to subtract 19 from both sides. So you get an answer of 2x squared equals negative 16. And then what we're going to do is we're going to divide both sides by 2. And you're left with x squared equals negative 8. So we know that if we want to find the square root of this, this would be equal to, we'd take the square root of both sides. So I'm just going to put that in a different color just to show you that I'm doing the square root of both sides. So that gives me x is equal to plus or minus the square root of negative 8. And then I'm going to break that down so that I have an imaginary number. So this becomes the square root of negative 4 and the square root of 2. So therefore, I have plus or minus 2i, because that's what my answer would be when I take the square root of negative 4, times the square root of 2. So your final answer would be plus or minus 2i times the square root of 2. Alright, now why don't you go ahead and try to pause the video and try B on your own, and then you can check back to see how well you did. Okay, so let's go ahead and work through this problem together. Alright, so we're going to subtract 25 from both sides. So you get 4x squared equals negative 48. Divide both sides by 4, and you get x squared equals negative 12. So then if you take the square root of both sides, you are left with x equals plus or minus the square root of negative 12. So then let's break that down into negative 4 and 3. So then that equals plus or minus 2i times the square root of 3. And that would be your final answer for part B. Alright, go ahead and start working on page 290, number 22 to 42. The answer key will be provided so you can check as you're working along, and I will see you all hopefully in Google Meet if you have any questions. Alright, take care. Bye.